The special theory of relativity. A brief intro. The ancient Greeks were the first one to say that the Earth was the center of our universe. But this guy, Nicholas Copernicus, in the 16th century said that the Sun was the center of the solar system. But were they totally wrong? In order to understand relativity, you must first understand frames of reference. With respect to the man on the scooty, the tree and the man are moving backwards. But with respect to the man standing over there, the scooty is moving forward. When we define the motion of an object, we tell it to be in motion with respect to a frame of reference. But what is the absolute frame of reference?
Now imagine yourself in a spaceship with no windows and no contact with anybody else. Can you determine with the help of some experiment whether you are at rest or in motion? If moving, then with what velocity through space?
In the 20th century, Albert Einstein did various thought experiments to determine such a kind of experiment, and he concluded that there is no absolute frame of reference. He came up with the postulates of relativity.
First postulate. The laws of nature have identical forms in all inertial frames. Second postulate. The speed of light in vacuum has the same value 3 × 10⁸ meter per second in all inertial frames.
Vigorous experiments such as the Michelson-Morley experiment also confirm the same. Michelson and Morley designed an experiment to find the presence of ether.
Power of the ether, an ancient force of infinite destruction.
Not this ether. Even though this experiment was a failure, it changed man's view on light forever.
Let us consider this situation where Iron Man is standing with a light clock of length L and the Mad Titan moving towards him with a velocity v. And in Thanos' frame, the Iron Man and clock are moving towards him with a velocity v, while he is stationary. Consider 3 intervals when the clock is moving towards Thanos. We notice that the light travels a longer distance than in the frame where Iron Man has the clock stationary in it.
Time dilation.
Let us just now calculate how much time extra does it take. Let L dash be the time the light takes to travel from M1 to M2 and back to M1 in Thanos' frame of reference. So L dash, by using Pythagoras theorem, we can say that it is equivalent to root over of L square plus Vt dash square by 2. And T dash is the time taken in Thanos' frame for the light to go from M to M2 and back to M1. So doing a little bit of calculations and substituting 2L by C, which is equivalent to the time in Iron Man's frame of reference, we can know that the time is taken by the light in Thanos' frame of reference is actually more than that of the time taken in Iron Man's frame of reference. And we obtain this as the final result, where T dash is always greater than T.
Length contraction.
While the light ray is moving from M1 to M2 in a moving frame of reference, it actually travels a longer distance than L while moving from M1 to M2 and a shorter one while coming back. So it does not actually add up to 2L for going there and coming back, but a little less than 2L because of the length contraction. These formulae are called the Lorentz transformations.
Another weird thing relativity does is that it changes simultaneity of events.
Now let us consider a train moving with a dog on it and you observing it from the outside. Now 2 lightning strikes occur simultaneously with respect to you. How would the dog perceive it from the train's frame of reference? The dog would perceive it in a different way. It would perceive the lightning strike happening in front of the train before the lightning strike which happens after, which is it would perceive A before seeing B. This is due to the fact that the dog is moving in the direction towards A and the light from A falls in the eyes of the dog before the light from B falls on it. The simultaneity of 2 events is thus dependent on the observer himself.
Make the ground shake.